Here's a wild number for you. The AI you chat with online has billions, sometimes trillions, of tiny little knobs inside it. And every single one of them was set, automatically, by the machine itself. Today, let's talk about what those knobs actually are. They're called parameters or weights. And once you get this, you'll finally understand what people mean when they say a model is bigger or smarter. Okay, let me paint a picture. Imagine an old radio with 100 little dials on the front. You're trying to tune it to a clear station. You twist one dial, the sound gets a little better. Twist another, it gets worse. So you go back. You keep twiddling until, finally, the music comes in crystal clear. That's basically what training an AI is. Except instead of 100 dials, there are billions. And instead of a human turning them, the computer turns them, very patiently, over and over. Those dials are the weights. Each weight is just a number that says, hey, how important is this little signal compared to that one? Stack billions of these weighted decisions together, and you get something that can write poems, recognize faces, or translate Japanese. The magic isn't in any one knob. It's in the combination. So how does the machine know which way to turn each dial? Here's where it gets cool. You show the model an example. Say, a picture of a cat, and you tell it this is a cat. The model takes a guess. Early on, it's terrible. It might say banana. So the system measures how wrong the answer was. That's called the error, and then it nudges the weights, just a tiny bit, in whichever direction would have made the answer less wrong. Then it does it again, and again, and again, billions of times. Learning, in a nutshell, is just adjusting weights to shrink mistakes. Think of it like a kid learning to shoot a basketball. First shot, way short. So they push a little harder next time. Too hard, it flies past. Pull back a hair. Eventually, muscle memory locks in. The model is doing the same thing, just across billions of tiny muscles at once. Now let's talk size. When you hear someone say GPT has 175 billion parameters, or this open source model is 8 billion, they're telling you how many of those knobs are inside. Older models had thousands, then millions. Then we crossed into billions, and the AI suddenly got really good. Like, surprisingly good. More knobs means more room to capture subtle patterns. The difference between sarcasm and sincerity, between a poodle and a mop. But, and this is a big but, more parameters isn't free. Every extra knob has to be stored somewhere. It has to be calculated every time you ask the AI a question. So a bigger model needs more memory, more electricity, more expensive computer chips, and it answers a little slower. Let me put it this way. A 70 billion parameter model is like a giant orchestra. Gorgeous sound, but you need a whole concert hall and 100 musicians. An 8 billion model is more like a really tight jazz quartet. Smaller, cheaper, faster, and honestly, for lots of jobs, it's plenty. That's why you're seeing this huge push lately for smaller, smarter models. Companies have realized that bigger isn't always better. Sometimes you want the orchestra. Sometimes the quartet runs circles around it for your specific task. So here's the takeaway. Weights are just numbers, billions of little dials inside the model. Training is the long, patient process of turning those dials to reduce mistakes. The more dials you have, the more nuance the model can capture, but the more it costs to run. That's it. No magic. Just an unimaginable number of tiny adjustments adding up to something that feels intelligent. Tomorrow, we're tackling one of the sneakiest problems in AI, when a model looks brilliant during training but flops in the real world. It's called overfitting, and it's basically the difference between memorizing and actually understanding. See you tomorrow on AI in 5.